Okay, in today's Project Euler program, we're going to do problem number 9. Problem number 9 is finding special Pythagorean triplets. So a Pythagorean triple is a series of natural numbers, so integers, for which a squared plus b squared equals c squared, and according to this, there is only one of these where a, b, and c equals 1000, and we need to find that. Okay, so admittedly, I don't actually know how to solve this problem, so I'm going to try a few things. I'm going to assume that I'm going to have to calculate c from this formula. So I think the first thing I'm going to do is that. So I'm going to have a number. I'm going to put a label on this. This is A, and I'm going to have another number B. I think I'm going to have to make these controls in the future, but we'll do this for now. And I'm going to have a couple of square functions, and I'm going to have to add these together. And then I'm going to have to take the square root of all of this. Yeah, this is going to be confusing. So I'm going to have to do this such that, see, the square root is going to be a problem because it's going to give me, when I take the square root, it's going to give me for most of these combinations, it's going to give me a non-integer value, and I want to be able to use integers so I can effectively use this quotient remainder and call this c. And I'm going to create a subVI from this, and this is going to be to solve for c based on a and b. Okay, so first let me check to make sure this is actually right. So a squared plus b squared, square root of that should equal c. Let's put in something that I know to be true. So if this is 3 and this is 4, then this should give me 5. Okay, great. So 2 double. I am a stickler for these. These are called coercion dots. So what a coercion dot is in LabVIEW is when you take one numeric data type and you plug it into an input that is expecting another numeric data type. So they are technically compatible, but it shows you this coercion dot to force you to acknowledge the fact that you are you have a mismatch of data types, and I don't like those out of principle. So I always do the appropriate conversion to make sure I'm handling that manually, to make sure that I don't have any unforeseen or unexpected results from coercion. So I am going to save this as a subVI here, and I'm going to call it solve Pythagorean. Oops, Pythagorean. Is that how you spell it? Pythagorean. Yep, I'm just going to call it solve Pythagorean. Okay, and I'm going to save this. And I think the next thing I'm going to do is put this inside a nested for loop. Create a constant. I'm going to create something that I know is large and just put a and b in here. And I want always a to be bigger than b. So I guess it doesn't really matter in this context because this is an add operation and none of these are dependent on the order of operations. So that's fine. And then I'm going to, I'm going to use the quotient and remainder and divide this by 1. So I can use this to check if this is equal, equal to 0. And if it is equal to 0, then I know that this number at least produces a Pythagorean triple, but that is not necessarily following this form. So let's just see what happens here. I'm going to take a and b, and I am going to concatenate them. and I want to make this concatenating and make this concatenating. And I'm only going to add conditional, oops, tunnel mode, conditional. I haven't quite figured out how to do this problem. So I'm going to do this and just see what this gives us. Create an indicator, oops, and another indicator. A's and B's. Because I don't actually know how many solutions to expect. If I can get this far, so this should give me, okay, yeah, that's not right. I need to increment this. Gave me all the zeros, which gives me a remainder of 0, so I don't want to do that. So I want to start at least 1, so I don't get that 0 problem, because that just gave me 1,000 zeros in a row, and I don't really care for that. Oh, I need to save this. This is going to be problem 9, special Pythagorean triple. Special Pythagorean triple. Oops. Triple. And we're going to run this again and see what we get. Okay, so 4 and 3 and 3 and 4 should be in here. Okay, so that's good. So I think this is working because 3 and 4 is definitely an answer. So I think now what I need to do is check for the condition that A is greater than B, the array is less than B, which is less than C. So I'm going to actually create another array here. I'm going to concatenate this one and make this C's. C's. Again, I still don't quite know exactly where I'm going with this. A's and B's and C's. Is this correct? Oh, I need to add the conditional. That's what's wrong. Tunnel mode, conditional. I need to have this the same oops. Need to make this the same condition as everything else. Okay, so what I should have here are 3 arrays of A, B's, and C's that all meet these criteria. And it looks like I do. So the 3, 4, 5 triangle, we've got those. 5, 12, 13 triangles. 8, 6, 10 triangles. And that looks correct. Just to check, because I actually don't know what all these are. Let's do 12 squared plus 5 squared. And then we're going to take the square root of that number, and I already know by doing this routine. Okay, so this is giving me Pythagorean triple, so this is correct. So now the next thing that I need to do is filter out. I'm gonna do this. So I'm gonna do a couple things. I'm gonna do 2i32 because I'm a stickler for these coercion dots. And once we get to this point, if I ever plug in a number to here, I already know because of this remainder that anything that goes into here is in fact an integer. And so I don't risk losing. There will be numbers that come into here that get truncated because they're not integers. So anything that is not a Pythagorean triple will have some sort of remainder here. But I don't need to worry about that being eliminated or losing information here because I'm already filtering for this conditional where the remainder is equal 0. So let's do this again. I should be able to run this. And now I want to put all this into another for loop. Oops. I also, these for loops, this is a sort of bad practice because I have potentially, because I've got this condition the same for all of them, I know they're not the same, but I do have this potential, if I were to modify this program later on, that these arrays are actually different sizes. If I did some modification here to change this program, I could definitely have that case. I'm not going to worry about it right now because I'm still just figuring this out, but just for the future, that could be an issue. So what I want to check now are these conditions. Oops. Less than. So I want to check that A is less than B and that B is less than C. And I want those both to be true. If they are true, then concatenate or then recreate this array of A, B, and C now with only solutions where A is less than B, which is less than C. So I'm gonna tunnel mode conditional, put the condition on all these again, tunnel mode conditional, tunnel mode conditional, and I'm gonna connect all of these up, and I'm going to recreate each of these, so make sure I get them right. So that's C, these are the A's, and this is the B's. Okay, so now in theory what I should have are A's, B's, and C's that meet not only the Pythagorean triple criteria, but also this A is less than B is less than C. And I think I do have that. 3, 4, 5, 6, 8, 10, 5, 12, 13. And so I should have that. Okay, so we're getting close here. Now the next thing I need to do, again, I'm doing this inefficiently, but I'm kind of figuring this out, so I'm okay with that. I'm going to take my A's and my B's, I'm going to put them in order this time into the for loop, and my C's, and I'm going to add these all together. Add. I'm going to add this to this, and then I'm going to add this to this, and I think I'm getting up here. Okay, so now this should equal, create constant, 1000. And I'm going to do this, we talked about this in a previous video, I'm going to add the conditional terminal so that this loop stops, and I'm just going to clean up this one, so that this for loop stops when this condition is met. And when it does, I should, indicator, so this is going to be A, create indicator, this should be B, and create indicator, this should be C, okay? So now, when this loop stops, A plus B plus C should be 1000, which will meet this criteria. So let's run that. Okay, and I very clearly have that. That's actually pretty convenient, A, B, and C. So 200 plus 375 is 575, plus 425 is 600, and then 400 more is 1000. Okay, so now all I have to do is multiply these numbers together. Multiply these numbers together, and then multiply this one by this one, and then I want the last value. So this is something that we haven't used in a for loop before. Whoops. Create an indicator, and I'm going to call this special Pythagorean triple. Pythagorean triple. Okay, now by choosing this last value for loop, because I have this conditional here, I can select a special condition for which this equals 1000. But rather than what the last value does, obviously, is give me just whatever the last value in the for loop is, and I'm going to use that for this interesting case where I've got this conditional terminal. So I should be able to run this and get my special Pythagorean triple product. So let's go check that real quick. This is problem number 9, and we can see here, there we go, 31,875,000. 31,875,000. So now we know we have this algorithm that kind of works. I'm going to talk about some things that we could do potentially to improve it. Delete this. I'm going to clean up this whole thing and see what we've got here. So the first and most obvious inefficiency are the multiple for loops. You can see in a lot of these, actually I am going to clean this up. So I think the thing that I'm having trouble here is like now that I know the answer, which is none of these go above 425, I could change this to 425 and this to 425 because I don't know which order they go in, and I would do less than half of the computations to get this answer than I am now, because I was doing it on 1,000 times 1,000 numbers before, and now I'm only doing it on 425 times 425. What ideally we would do is create some type of function that is checking criteria that show when A plus B plus C is over 1,000. And whenever it is, we end this for loop and we go to the next number until we cycle through all loops. The other thing that we could do is move this logic and this logic, and this logic here inside of this one for loop, and only have the case where we search and modify these conditionals so that we include this logic as well, and then stop this inner for loop when we reach that number. That is something we could do. It will complicate things a little bit because we are checking this less than criteria. Actually, no, I think that would be okay. We could do something like that, and that would make it a bit more efficient. There's probably other things that we could do. The problem with my algorithm is that I have to guess ahead of time what I think these numbers are going to be, which I don't really like. I prefer to do something programmatically. But in this case, we don't really have that luxury because I'm not, I guess, that smart to be able to figure this out. So I think we're going to stop it there. Here is an algorithm that works to find a special Pythagorean triple. You can, in theory, make these as large as you want and solve for any arbitrary number here, which of course was true, to solve this problem. So that's it. Relatively inefficient version of problem number 9. See you next time.